All right, here we go. So, 6th grade. All right, now what I'm going to do is I'm just going to go back to the top here. We're going to start with question number 26. All right. Now, again, guys, seriously, these are they're not that easy. All right. I specifically wrote them so it's hard. All right. And it's not just one step and that's the answer. You got to reason through it. And sometimes it's better if you just draw a picture out. And that's what I'm going to try to show you on here. But first, I'd like to see, Harrison, did you get an answer for 26 at all? What did you get? 52. Good. What did you get? I'm on 26. 40. What about 40? 40? 40. Wow. You guys, I'm pretty happy. It is 40. I'm really proud of you. If you got 40. Now, what I'm going to do is, again, I don't really care what you got. Listen, and again, some of you guys I'm really getting fussy on because I want to stop the games now. I don't want to be funny anymore. I'm working too hard. I'm not interested in that right now. I got to concentrate so I can get you a good grade on this test. It's hard. All right? So concentrate. Listen to what I'm saying. If you can't draw, obviously I'm not the best drawer in the world, but it helps. Or it does help. All right, so here we go. What we're going to do is we're going to try to draw a shelf, all right, that is 20 inches wide. So to draw a shelf that's 20 inches wide, I kind of did this, all right, I made like a little, try to draw so it would be a shelf, right? And then what we did is from there, all right, you could probably try to see that this is what my shelf was going to look like, all right? And on my shelf, all right, we're going to draw the cassettes and we're going to draw the CDs. All right. Now, again, it's not really that big a deal, but there is my shelf. All right. Now, what I'm trying to demonstrate is, and it was kind of funny because you can see how kind of even old this is when I first made it. The CDs were kind of popular, right? Does everybody know what CDs are? Yes. Right? Or DVDs is kind of the same thing. And then, does anybody know what a cassette is? Yes. So cassettes are what was before CDs. That's what you put music on. All right? There's little plastic things that, yes. All right? Not the vinyl records. That was before even that. All right? But they made it on the little cassettes. Yes, that's exactly correct. So now, here is what I want to show you now. All right, here's what I have, and I want to put up here 20 inches. All right, it's 20 inches wide. And so what I have is, I have 8 cassettes. So what I want to demonstrate for those of you guys who made a mistake, even though most of you got it right, is I'm trying to draw, there's one, right? And then there's another cassette. And then we could draw another one. And how many would I be drawing?
3.
Well, how many do I need? 8, right? So the width of one of them is what? 5 over 8. And I have how many altogether? I have 8. Right? So if I stack those up 8 next to each other, how many inches would that be? How much? 5 inches. All right? So all of this space right in here represented 5 inches. All right? Does everybody agree with that? All right? Which means that how many inches left?
15.
That's right. So now we can say from here to here is 15 inches. Everybody good with that?
Sorry.
All right, I'm listening. Because there are how many CDs or how many cassettes? There are 8, and each one is 5/8 inches wide, right? So you would have 8 5/8, and 8 times 5/8 is 5 inches. Agreed or not? Because you got the right answer, right? You told me 40, right? So you said 52. Okay, so we're fixing it now. You with me? Now again, listen to me. I'm trying to help you understand it. I don't want you to say, yes, I got it if you don't. All right? Now, do you understand why it's 5 inches or not? You can say no, So I can draw it better even for you. I can draw it even better. That's exactly right. So check that on your calculator. 8 times 5/8. Should be obvious, but we're using a calculator, so we're going to double check. So that's 5 inches, right? So now I have 15 inches of space left. Do you agree? Now I'm trying to figure out how many CDs I can put on here. So I'm trying to figure out how many CDs I can put on there. What am I doing to that 15 inches? What am I doing to it? I'm dividing that space up. There you go. So now what you're doing is you're telling me 15 divided by 3/8. And do 15 divided by 3/8, please. Yes, there you go. So you could put 40 CDs on that shelf. You could put 40 CDs on that shelf. Everybody happy with that?
Oh, I saw a video.
Okay, good. That's what I'm saying. Come on.
I know.
Come on, I'm going to make you go home. I'm going to make you listen to this video. You can hear yourself talking the whole time. All right? And mumbling as well. There you go. All right? Here we go. Now I'm on 27. All right? Now I was pretty sure you guys would have a good understanding of this one. Did you get this one, Eric? 3/4. Don't be sorry. Come on, talk it through. That's right. So 3 hours, it would go off 4 times. And we want to know how much it's going to go off 12 times. How many? Yes. Okay, I like your train of thought. That's not a problem. Someone else, tell me. Yes, exactly. Here's what I'm trying to show you now. Again, in my mind, what I would want you to picture is this. I would want you to go this. That this is 12 hours. And once again, I'm just trying to demonstrate that I'm taking the 12 hours and every what? 3/4 of an hour, the alarm's going to go off, right? So again, here's another, here's another, here's another. So what am I doing to the 12 hours? What am I doing? Well, I don't like that word, but yes, what am I doing? Yeah, that's what I'm saying. Even though I understand what you're meaning, you're taking the 12 hours and you're dividing them into what? 3/4 of an hour. Yes, you would. Very smart today. I was going to say that's why most people miss this. Yeah, it would be 16, except the 16th time it would be at what? It would be at midnight. Shh, hold on a minute. Just listen for a second. She said something brilliant. Right? So we should have done 12 divided by 3/4, and that would be how much? That would be 16. So at midnight, it'll be the how many time it's gone off? It'll be the 16th time. But for those of you guys who are reading carefully, it says how many times will it go off what? Before midnight. So the answer should technically be what? 15. If you put 15, pat yourself on the back. You are a great reader. You're a great reader. I'm telling you, just listen. going to mark yours minus 25.
Ooh.
No, seriously. You understand what I mean? That's kind of a trick question, right? You know what to do. Everybody knew 12 divided by 3/4 is 16, right? That's what I'm trying to tell you. On a lot of standardized tests, some of you can do better if you just do what? Read more carefully. Because you know how to do the math. You just get tricked with reading. That's why I'm telling you, be careful. Be careful. Brilliant. Very good job. Very good. What?
The only thing I have a question is how can you tell if we divide, add, minus, multiply the word problem?
By drawing it out. And honestly, I'm always trying to tell kids this. Experience. You have to do the problem. Honestly, there is no substitute for that. That's what I'm saying. I know it's harder. All right? You just have to draw pictures. That's why I'm not a very good artist, but drawing it out helped me out tremendously. There's no way I can just look at these and tell you how to do the problem. I don't even do that right now. All right? I draw them out so I can see it better. And then eventually you'll make connections, and you won't have to do as much drawing. All right? Just like this. This one, before 12, is just a crazy problem. All right? So if you put 16, I don't mark it wrong. I just say, hey, should have read carefully. Right? So now, look at 28. I just want to make sure, even though the answer was there, I didn't mean for it to be there. All right, on the test, it'll be better written. This means 3/4 what? Did I go to that? So it's going to be what? 3/4 divided by 8/3. Just do that on the calculator for me. Yeah, 9/32. All right, it's called a complex fraction. What? Well, we're not there yet. We're right here. I promise you, Harris, I'm going to take care of you. Okay? What? Yeah, multiply by the reciprocal. The point is, I know you can do. I can make them harder even. All right, I'm not interested in that. I'm trying to teach you how to use the calculator. That's what we're doing. All right, part of the lesson is the calculator. All right, here we go. Now, 29. Let's see who's got 29 correct. What'd you get? 4, 4, 5, 4, 6, 5, 73. That doesn't, come on, man. You got to be smarter than that. 21 feet, you're going to put 73 cones up on 21 feet? Come on. Go. 5, good. 6, 6, 6, 4, 6. All right, so now again, guys, I'm telling you, I just think you should know this. What did you get, Jackson? 5. All right, let's see who's right. So again, here we go. All right, I'm drawing it right now. There's no reason to argue about it. This is what's messing me up. I'm telling you, listen to yourself. You'll hear you interrupting continuously. There's no reason. We're drawing it right here. Not to prove anybody wrong. All right, let's just do it and see. All right, so how long is my, how far am I going here? 21 feet. So I'm hoping everybody puts down 21 feet. All right. Now, I'm not a very good person at making cones, but I can make something. All right. Let's make a little cone right here. All right. So here's my cone. All right. Now for my cone. All right. I'm going to place a cone every what? 3.5 feet. So here's where I start, right? Here's where I start, right?
Yes. Oh, skip it.
It says, don't put a cone at the start or the end. So, where is that? How far down the street? 3.5. How far now? How far? 7. How far now?
11.
How far now? Come on, guys. How far now? 14. Come on, we're counting by 2.5, right? Or 3.5. Then the next one goes where? 17.5. And so the next one would be at 21. Do I need that one at the end? No. Cut that out of there. So how many cones was I supposed to have? Supposed to have 5 cones. Supposed to have 5 cones. Harrison, what? Because I just counted, Harrison. Harrison, I'm telling you, I don't know what to tell you. I just drew it up on the board for you. Now, who can tell what his problem is? Tell him what the problem is. You're not drawing the picture, number one, but even better than that. Well, no, the problem is you're right. You just take 21 and divide it by 3.5. I agree with you. What's 21 divided by 3.5? 6. So why did we do 5? Tell him. You don't need 1 at the beginning or the end. So what I'm showing you here is, this is what I'm not understanding. That's 3.5. That's 3.5. That's 3.5. 3.5. 3.5. 3.5. All of that right there is how many feet? 21 feet. How many cones did I use? There you go. Now, why do you want it to be 6? Well, why do you want it to be 4? Oh, now let me tell you something. Hey, listen to me. This is what I'm trying to teach you, buddy. There is nothing whatsoever. Nothing wrong with your thought process. But now I'm going to tell you what the mistake is. When you divide, there's not 1 here. So normally you start at what? 0 when you start counting. You don't start at what? You don't say 1. This is 0, right? So what I'm trying to show you now is really helpful. I can teach you a lot if you listen to me today now. And I know you're listening, but what I'm saying is I'm going to show you why you make a mistake on this one. You hear me? So here, from here to here is 3.5. The first cone goes right here. Do you agree with that? And then you just count again. That's another 3.5. That's another 3.5. That's another 3.5. So if you want, this could be 7. That could be 10.5. That could be 14. This would be 17.5. And this right here would be 21. Now, the reason why I think I think you might have just miscounted the 3.5. I'm not. Oh no, you subtracted 1 from the front and the back after you did 6. Yeah, but see, we never put 1 in the front though. Because when you count, watch. When you count, I'm trying to show you. 1, 2, 3, 4, 5, 6 spots. Correct? But we don't start with what? When we start counting, we don't say 1. This isn't a 1 right here. You understand what I'm saying? It's really what? 0. Because we haven't gone anywhere. Listen, I hope that makes sense. But listen to me. The other thing I want to tell you is this. I understand exactly the mistakes you're making. That's why I try to tell kids you have to draw it out. Because sometimes it's unclear about what to do at the front end and what to do at the back end unless I can see it. Now, let me ask you this. Would it be a fair question to say 700 feet? Now, why would that be a little bit more unreasonable? Yeah, it's a lot to count up. If that's the way I want you to do it, I'm not going to ask you to count to 700 by 3.5. Does that make sense, everybody? Right? Although we could do that, it wouldn't be that big of a deal. Okay? All right? But now my question to you is this 29 okay now? Because we're going to get to more tricky problems too. That's what I'm saying. Let's figure it out right now. So as we get to the harder problems, you'll be okay. What? There's no, if I could do any better, I promise you I would. But here's what I'm going to try. Thank you, Harrison. here, and here. That's 21 feet. So I'm putting a cone every 3.5 feet. That's the first time I put a cone. Then I put another cone, then another cone, then another cone, then another cone, then another cone. Uh-oh, except what? I don't want a cone at the end. So I'm not including this guy down here. All right? Yes, ma'am. As long as you're okay. As long as you're okay. And that's what I'm trying to tell some of you guys. That it all has to do with experience, guys. And I mean that. That's why I'm saying draw the picture. Some of you are stubborn and you're not going to draw a picture and then you're not going to get as good a grade as you can. If you would learn to draw the picture, it would be better for you. And you'd do better on your test. All right, it's just that simple. And then you would trust yourself more. Go. Yeah, if I said this, like for example, if I said how many numbers are there from 1 to 10, you would say what? That's right. You think there's 9, but there's actually what? Because we're counting this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it matters if we're including the first one as a number or not. If I said how many numbers are there from 0 to 3? 4, because you're starting with what? 0. 0 is a number, right? Right. But if you're just counting distance, if I say from 0 to, if I went from 0 to 10, right, as a length, I've gone what? 10 yards or 10 feet or 10 whatever, right? Because I'm starting at what? 0. It's like saying if I went from the number 1 to 5, how many numbers did we move? 4, right? But if I said how many numbers are there, you would say what? 5, because we're starting with what? 1, 2, 3, 4, 5.
I thought of it as kind of like a car, you know, you say like 0 to 60.
That's exactly. Right? Just depends. Are you counting the first number or are you not counting the first number? And that's just very tricky questions. That's why I say you have to be a good reader to get these correct. All right? Now, number 30, I'm expecting everybody to get this one correct. What? 4, 3, 2, good. 4, 4, 3, 4, good. 4 and a half. A 4 and a half bounce. What? How much? 4, 4, 4.
Oh, no, I got
3, 3. Okay, now again, here we go. I mean, don't marvel at my drawings, okay? I know some of you are impressed, all right? I did, my major was math and my minor was arts, okay? So don't be jealous, all right? Here we go. So how tall is that? 6 feet. So we're at 6 feet here, all right? Now, look how perfect I can draw a circle, all right? So there is my ball, all right? Here we go. Now, what is my ball doing? Now, everybody knows, I think logically, that if the ball hits the ground, it's not going to bounce up exactly the same height ever. Never, regardless. It can't do that. All right? So if the ball hits the ground, all right, and bounces up, it's never going to bounce to the same height. All right? It's always going to be a little bit less. So in this case, they're telling me that when it hits the ground, it bounces and comes up how much? 3/4. 3/4 of 6. So how do I figure out what that is? Yes, ma'am, that is correct. So 6 times 3/4. So 6 times 3/4 worked out to be what? 4 1/2. So now the ball came up to a height of 4 1/2 feet. All right, so it came down, hit the ground, bounced up. Now it's bounced up 4 1/2 feet. Now it comes back down, hits the ground, and comes up how high? 3 3/8. So are we still going to hit the ground again? Yes, because 3 and 3/8 is not less than what? Less than 3. So now the ball comes up to 3 and 3/8, comes back down, hits the ground, and comes up to how high? 2 and 5 over 32, or 5/32. Do I agree with that? 5/3. I don't think so. Do 3 and 3/8 times 3/4. See if I'm right. 3 and 3/8 times, what was it? 17 over 32?
Yeah.
All right, thank you. So 2 and 17/32. Now, is that where we stop? Because it's less than, not 6, but less than 3. I know what you meant. Less than 3. So now how many times did it bounce? 3 times is the answer. If you did 3, pat yourself on the back. What?
I accidentally looked at it. I just did 6 times 3 over 4 and I got 9 over 2. So then I did 9 over
6. Yeah, and you keep going until it's less than 3.
I
Now, a quick way to do that, you could say this. You could say, everybody type this on your calculator. 6 times 3/4. I'm going to try to show you something on your calculator. It's kind of cool. Then if you hit times, you don't have to put in the answer. It automatically puts in the answer for you. Times 3/4. And then do times 3/4 until you get a number less than 3. And how many times do you hit times 3/4? 3 times. That's okay. That's what you're here for. Getting the experience. That's what I'm saying. Yes. Well, yeah, so on the third bounce, you bounce up this 2 and 17/32 speed. No? Why not? The ball can't, every time the ball bounces, it always goes exactly 1 foot. It can't go a fraction of a foot. Yes, absolutely it can. When you hit a baseball, it's not always 65 feet or 10 feet. Sometimes it's never striking out all the time. Go. I'm listening. Very good question. All right, very good question. So let me ask you this. All right, somebody asked me that earlier, so here we go. I'm going to try to do my best job explaining this. All right, first and foremost, I tell my kids that of in math, you're just going to use because that means multiplication. Now, not all the time, but most of the time, of means multiplication. But now, here's what I'm always trying to tell kids. Let's say it was 10 feet. And every time it hit the ground, it went half of the original height. No? So it started at 10 feet. How high would it bounce on the first one? Now, how did you get that? Right, or 10 times 1/2. That is correct. Well, because it's saying that it does 3/4. Or let's say I just made up and said half. Right? So anytime you would take half of something, you're going to divide by 2. The problem is, this isn't very good because you can't divide by 3/4. Right? But 3/4 can be a decimal 0.75. So you could say, I could take 6. Right? Now, think of this. 6 again. And again, I know it's kind of hard because it's a fraction, but that's why I use 1/2 as the easiest thing. All right, you should be able to tell me half of 6 is what? 3. So I did 6 times 1/2 to get to 3. Okay, so let's do this. Do me a favor. Do 6 divided. Did you think it was division? So do 6 divided by 3/4. And what was it? 8 times, right? So, um, so I'm trying to see if I can do this. All right, I'm gonna erase this and see if I can explain it better. Here we go. So, if I drop, do I want the height to be more or less than 6? So if I divide it, is it going to be more or less? Exactly. Now listen, I'm going to try to tell you something too that's not easy for kids to understand. Anytime I divide by a number less than 1, it's getting bigger. Because multiplication and reciprocal. You know what I'm saying now? So you agreed with me that it has to be getting what? It has to be getting smaller, right? So the only way to do that to get smaller is to go 6 times 3/4. Because 3/4, okay, let me try this too. All right, I'm one more time. I think I can get it now. All right, I think I can explain it better this way. So here is 6 feet. If I want 3/4 of that, do I want more than 6 feet or less than 6? That's right. You with me? So I'm going to try to draw 3/4 for you. Not very good, but I'm going to try. So that represents 6 feet. I'm going to try to do this. Is that, I mean, you can kind of visualize that, right? So this right here represents 3/4 of 6. You agree with that? So now what I want you to do is take 6 on your calculator. Please, everybody should be doing this. 6 and divide it by 4. 1.5, right? So this represents, this represents 1.5. This represents 1.5. This represents 1.5, and that represents 1.5. Do you agree with that? You agree with me? So I want 3 out of 4. So how many would I have? That's right. And 3 1.5 is guess how much? Or I could have just done from the very beginning 6 times 3/4. Try that and see if that's the same thing. No, 3/4. 6 times 3/4. I don't know what I said. Sorry. Same thing. Did I help you a little on that now? I know. Very good. Because watch this. I can understand. I can do that easily now. If I multiply by 1, what am I doing? Staying the same, right? If I, what's 6 times 1/2? What's 6 times 1/2? Now listen to me. Listen to me. This will help you. What's half of 6? And I just used the word of. Half of means multiply. Because remember, 6 times 1/2 is 6 times 1 divided by 2. Does that make sense now? So here's what I'm telling you. If you take half of something or 3/4, you're taking less than all of it. You know what I'm saying now? If I say 9/10, give me 9/10 of everything you have, I would be taking almost everything, but not everything. You agree with that? So if I multiply by a number between 0 and 1, it's going to go what? It's going to go down. If I multiply by a number greater than 1, it's going to go what? It's going to go up. Does that make sense? Right? And if I multiply by a number between 0 and 1, that means I'm taking part of what you have. I'm not taking everything that you have. Is that good? So when you say 3/4 is high, you're not going as high. You're going a little bit less. All right, quickly. Did you have a question now? All right, let's go. We only have a couple minutes, so I want to try to do this one too. All right, everybody think about this now. I've got a water cooler that contains 10 gallons. If you drink 2/3 of a gallon each day, how long will the water last? 15 days.
15 days.
15 days. Are we pretty good with that one?
Yes.
All right, here we go. Come on. No celebration for being right. We should be used to being right. It's not like, thank goodness I finally got one right. We're not celebrating that. It should be, of course we got it right.
Oh, yeah, of course I got it
Right? So there's no reason. It's kind of like when you make a basketball shot. You don't need to celebrate because you're used to doing it. Right? I know some of you. All right.
I'm used to making layups. I don't make the.
Okay, here we go. Now, in this particular case right here, it says the winner for class president got 3/5 of the votes. So what fraction did they not get?
Fraction?
What fraction did the loser get? If the winner got 3/5, the loser got?
80/200.
Well, yes, but I want to know what fraction. If the winner got 3/5, the loser got what? Remember, 5, the denominator is always the total. If the winner got 3 out of 5, the loser got?
4, 2 out of 5.
Yay. That's right. You see what I'm saying, right? No, well, there's one part of the question. It said, what fraction of the vote did the loser get? So the winner got 3/5, and the loser got what? 2/5. Now, I didn't say the votes, right? So it's the same kind of process here. This is for you, right? If the winner got 3/5 of the vote, we would simply do what? Yes, 3/5 times 200. And what's 3/5 times 200, someone? How much? Is that right? That's okay. The winner got 120 votes. And if I ask you about the loser got 80. All right, hold on a second. Right, here we go. So now one more time to summarize that. The winner got 3/5. The loser got 2/5, right? Because there has to be a total. You either win or you lose. All right, that's why it has to add up to 1. All right, and I think we learned a good lesson today about 3/5 of something or 2/5 of something. All right, that just means multiplication. Tell me.
So I did it and I got the answer right. I multiplied, but I just sometimes don't. I thought you at first, because my dad helped me on this one. I thought I was supposed to divide.
Okay, well, was that right? Or we just had a whole lesson, if you were listening, on why of means multiplication. Now you know of doesn't mean division. Right? It means what?
Multiplication.
Most of the time it means multiplication. All right. Thank you, guys. Tonight, review and do a couple more problems, and we're going to finish up tomorrow. I know you guys are upset. The test we have to postpone until next week.
Yeah, no, I'm so sad. Wait, eat it.